Welcome back. We're in 38B, designated roots. What does designated roots mean? Well, first we have to understand what a root is and why and how we can get there. So when we're working a quadratic formula or a quadratic equation, and this should say equation, sorry, not formula. I'll put that up here. When we work at a quadratic equation, we're setting it equal to 0 because then when we factor it, we can specifically say that one of these is going to be equal to 0 because it says equal to 0. And we know when we multiply something by 0, the answer is 0. So if one of these is 0, then we can definitively say that x is either going to be equal to 2 or 3, because then we can set each factor equal to 0, right? X minus 2 is equal to 0, or x minus 3 is equal to 0. And when we solve for x, we get that x is equal to either positive 2 or x is equal to positive 3. So we can definitively find the unknown value of x in a quadratic equation through finding the roots of x and setting it equal to 0. That is how we can be very definite about solving that problem. So designated roots is all about working a quadratic equation backward. That's where we designate the roots first. So we are given the potential roots of x, and we have to turn around and put that into the original quadratic equation. We just have to solve it backwards. That is all designated roots means. It means let's put these factors in and go backwards with it. So I'm going to erase this, and we're going to start with our first example problem, 38.5. And here are our designated roots. We want to write the quadratic equation with, it's going to tell us the lead coefficient, and that is going to be what, the x square is with. Lead coefficient, if I can spell coefficient, is equal to 1. And our designated roots are negative 3/5 and positive 1/2. Those are our designated roots. So we just have to work it backwards. So if we have x is equal to negative 3/5, then one of our factors is going to be x plus 3/5, right? Because if we add it to both sides, that's what we get. And if one of our roots is 1/2, then we're going to subtract this from both sides. And the other factor is going to be x minus 1/2. And we'll set that equal to 0. We don't have a lead coefficient other than 1, so there is no factor to have to deal with here, right? So that's fine. So we leave it like it is. Now we just multiply and distribute. X times x is x squared. That's going to be plus 3/5 x minus 1/2 x minus 3/10. So if we convert these to tenths, then this is going to be 6/10. Let me get the little small one here. It's going to be 6/10, right? And 5 times this would be 5/10. Which would make this x squared plus 1/10 x minus 3/10 is equal to 0. That would be what we would end up with as our quadratic equation given these designated roots. It's that easy. We're just going to solve it backwards. You just put in your factors from the roots that you're given, do the distribution, and then resolve your like terms. That's all you have to do. And this is the answer, right? That's what I'm looking for. So let's do example problem 38.6 and see what other variations we can come up with for solving. So 38.6, all right, so we have a lead coefficient of 1. So our LC is equal to 1. And the roots are 1 plus the square root of 2 and 1 minus the square root of 2. How about that? So if we have x is equal to 1 plus the square root of 2, then we are going to have to take this as a whole and bring it over. Subtract it from both sides. So x minus 1 plus the square root of 2 is equal to 0. So this is one of our factors. So this would be, let me put this in a bracket, x minus 1 plus the square root of 2 times, and then this one, the other one would be 1 minus, so we would say x is equal to 1 minus the square root of 2, put that, subtract this whole thing from both sides, so x minus 1 minus the square root of 2 is equal to 0. So this is our other factor, so we put that here, x minus 1 minus the square root of 2, all of that is equal to 0. So now we can simplify this by getting rid of the parentheses. So that would be x, that'd be minus 1 minus the square root of 2, and then x minus 1 plus the square root of 2 is equal to 0. So now we can do our distribution. And for this, I'm going to use stacking over here just because when we have more than 2, it gets really complicated. So x minus 1 minus square root of 2, x minus 1 plus square root of 2. All right. So let's start with square root of 2. So this times this would be a negative 2. This times this would be a negative square root of 2. And this times this would be x times the square root of 2. So then we have 1 times this, so that'd be a positive square root of 2, positive 1, and a negative x. I'm going to put my negative x back here. This would be a negative x times the square root of 2. This would be a negative x, and this would be x squared. And I'll put it right here. So now let's look and see what we have. So I have x squared. This cancels. This cancels. I have negative 2x, and I have a negative 1. So x squared minus 2x minus 1 is equal to 0. And that is actually the correct answer in the book, so I did it right. But you see how that works when you have a complex. You set the whole thing equal to 0, put it in parentheses, and then bring the whole thing over, subtracting it from both sides. Okay? All right, so that would be the answer to this problem. And that's all we have for 38B, designated roots. So if you have any questions, please feel free to ask, but we're going to do some practice problems following this video, and then we'll move into 38C, overall average rate.